Hi guys, welcome back to the next video. In this video, we are going to understand and explain about how multi-cloud architecture works. Now, this is going to span across AWS, GCP, Azure in a real enterprise environment. So we're going to look at these activities, the architecture over here, and we're going to understand a little bit about the design, connectivity, identity, governance, and workload placement. So in a correct format. So in this multi-cloud architecture, I'm gonna firstly talk about when do we use multi-cloud, um, you know, architecture like this. So let's understand when multi-cloud is a need. Not every company needs multi-cloud, but typically in most case scenarios like vendor lock-in avoidance, like for example, you want to go and get stuck in AWS, that's kind of a bad thing because always there is other multi-cloud people who always gives a different offer for you guys. Okay, and that offer can be the best offer, so it's always like you don't get stuck with one vendor. So just to avoid the vendor lock-in, we any big companies, they normally have connection with multiple cloud routes, and they host different applications on different clouds. Basically, the contract they have with these vendors, because the AWS or GCP or Azure does not only have the cloud business, they also have other business as well. So it depends on the customer what they prefer, or what the kind of contracts they have with these companies. For example, a customer who has a contract already with Microsoft will obviously choose Microsoft, and who has this Office 365 and they have just heavily dependent on Microsoft will always choose Azure. As well as there are these companies who has a lot of business with Google or using Google G Suite will always go for Google Cloud. Or people who has get a better offer on AWS, they go for it. But again, a lot of customers try to avoid the lock-in avoidance, which means they don't go with one cloud partner, they go with multiple partner. There's also regulatory and data residency requirements as well, where GCP, AWS, and Azure offer different kind of agreements, and their terms and conditions are completely different, and which is suited for different organizations for that matter. Now, mergers where companies already use different clouds, so that also is a reason. And also, the best service offered from each cloud will differ, so that is also there. For example, GCP for analytics, AWS for metro services, Azure for enterprise integration. So, these are some of the strategies they normally use for multi cloud architecture. So multi-cloud is a strategic decision, which is sometimes it's not a default choice. Sometimes people go for a specific cloud, and sometimes they go for multiple cloud partners as well. In terms of connectivity, let's talk about the connectivity between clouds. Yes, there is possibility, and there is also connectivity between cloud systems. So when you are using EC2 EKS on AWS and you want to use different services on these GCP and Azure, you have to connect these environments. So we cannot treat cloud as an isolated environment, but we need to secure the communication between them. So this is something called site-to-site VPN is there, which is dedicated. Which is used for connecting between different sites. Also, you can use other options like dedicated connections like AWS Direct Connect, Azure Express Route, and GCP interconnector. So these are some of the options which you can use in terms of connecting these different to one another. There is also the enterprise environment where we use dedicated connections for primary traffic and VPN as backup. So traffic is routed through the controlled network points. Security is enforced at every connection point, making sure that the communication is secure on the connection. So the next one is identity and access. This is where the most important part or the hardest part working with the multi-cloud environment. So You must have a centralized identity provider like Active Directory or Azure AD, where in which a user authenticator once and then they can access the federated environment across multiple clouds. Each cloud then maps identity and roles and permission. This is to ensure that the consistency access across all the cloud environment, better auditing, and also reduce management overhead. So these are some of the advantages of using, you know, having a integrated identity provider or central identity provider. In terms of workload placements, you should think like an architect over here, where the key decision is where your workload will run. So, for example, we don't randomly deploy across multiple clouds. We have a strategy. We decide based on cost, performance, service availability, and compliance requirements. For example, analytic works could be done on GCP BigQuery, compute heavy workload runs on AWS, and enterprise application runs on Azure. So this is what we've been like talking from the beginning. So if you're gonna keep this as straightforward as it is, then you can go for a dedicated instance on your AWS, and you have the analytics load on the BigQuery. You can run BigQueries on that, and then you have the enterprise applications which you can use on Azure. Now, data inconsistency is one of the important activities over here. So, when you talk about the data management, that's again a big challenge over here. We need to ensure that the data is consistently across the all the cloud environment, securing data transfer and minimizing the latency. We may use replication strategies, APIs for synchronization. However, excessive data movement increases cost and complexity. So, a data oriented architecture should be carefully designed and how it's going to be working with us. So all these small items I'm telling you about, or the high level topics we are talking about, should be all have their own individual architecture, in which we will be talking about how that items are going to be talked about. So this is just a high level vision on using multi clouds. So here, the next one is about the security and governance. The security becomes more complex in multi-cloud environments. So each cloud has its own IAM model, security tools, policies. So we need a centralized governance over here, which standardize the policies across clouds, logs and monitors. Monitoring aggregator needs to be installed, and compliance checks should be made. This is to ensure that the encryption and transit and rest, and as well as consistency across the controls. Monitoring tool also needs to be deployed over here for monitoring, and for relying on not just cannot be relied on one single cloud tool, but then monitoring across multiple cloud tool is going to be little challenging, but then it's doable. Like having a centralized login platform, cross cloud monitoring tools can also be used over here to have a visibility across the entire system which you have out there. Now, in terms of a real world scenarios challenge, multi cloud, sounds good in theory, but it comes with real challenges like increased operational complexity, skill requirements for across multiple cloud platforms, higher cost if not optimized, complex troubleshootings. So these are some of the challenges which you may face while setting up the multi-cloud environment. On an overall level, the multi-cloud architecture works real in enterprise level. It's not just about using multiple clouds, but about designing connectivity, identity, governance, and workloads carefully. If you are prepared for an architecture or a lead role, this is a critical area for you to understand. And you should also know a little bit about each of these clouds to design such an architecture, and a very deep knowledge on each cloud to understand, the low level architecture for each of these components, and also understanding like how you're gonna increase the operational capability and how to avoid higher cost. Thank you again for watching this video. I'll see you in the next one.